Hello everyone, thank you for stopping by. My name is Bino, and in this video we will determine the particular solution of this separable differential equation. We have the following second order separable differential equation with the initial conditions dy over dx is equals to 3 over 5, x is equals to 1, and y is equals to 1 divided by 5. We have the x squared, which is multiplied by the second derivative of y with respect to x, and this is equals to x to the power 6 plus x cubed minus 2x squared. We divide both sides of the equation by the x squared, and that x squared and that x squared will cancel out, such that the second derivative of y with respect to x will be equals to x to the power 6 plus x cubed minus 2x squared, and each and every term will be divided by the x squared. So every term on the right hand side is divided by the x squared, and that x squared and that x squared will cancel out each other, and the second derivative of y with respect to x will be equals to x to the power 6 plus x cubed minus 2, and since the denominator and the numerator have the same base, we will minus the exponents. So this will be 6 minus 2, and here we have x raised to the power 3 minus 2, and the second derivative of y with respect to x will be equals to x to the power 4 plus x minus 2. On the left hand side, we have the second derivative of y with respect to x. If we were to differentiate this, we will get the third derivative. But if we were to integrate this, it will take us back to the first derivative of y with respect to x. So for this reason, we are going to introduce the integral sign both sides of the equation. On the left hand side, we have the second derivative of y with respect to x, and we are introducing the integral with respect to x, and this will be equals to, so we also have to introduce the integral on the right hand side. So we have the integral of x to the power 4 plus x minus 2. We also introduce the dx. The integral of the second derivative of y with respect to x will be equals to the first derivative dy over dx. This will be equals to the integral of x to the power 4, which is equals to x to the power 4 plus 1 divided by the 4 plus 1. The integral of the x will be equals to x to the power 1 plus 1 divided by 1 plus 1, and the integral of the negative 2 will be equal to negative 2x plus our constant c. From here we simplify. The first derivative of y with respect to x will be equals to x raised to the power 4 plus 1, which is equals to 5, divided by 5 plus x squared divided by 2 minus 2x plus c, but we have to determine the numerical value of the c using the initial values that we were given as dy over dx is equal to 3 over 5, x is equal to 1, and y is equal to 1 over 5. So we have dy divided by dx is equal to 3 divided by 5, and the value of x is equal to 1, and the initial value of y, which is equal to 1 divided by 5. So in the place of the dy divided by dx, we substitute the 3 over 5. And this will be equals to, in the place of the x, we substitute 1. So 1 raised to the power 5 will be equal to 1 divided by 5 plus 1 squared, which is just 1. And we divide this also by the 2, minus 2 multiplied by 1, which is just 2, plus our constant c. So the 3 divided by 5 will be equal to 1 divided by 5 plus 1 divided by 2 minus 2, which is equal to negative 13 divided by 10 plus c. And from here, we take this negative 13 divided by 10 to the left, and it's going to change sign from negative 13 divided by 10 to positive 13 divided by 10. And this is equal to the constant c. And our constant c will be equal to 3 divided by 5 plus 13 divided by 10, which is equal to 19 divided by 10, which we can also express as 1,9. So we have determined the value of c as 1,9. So we substitute the 1,9 into that equation. So we copy and paste. So let's paste this. And our first derivative of y with respect to x will be equal to x to the power 5 divided by 5 plus x squared divided by 2 minus 2x, and the constant c we determined as positive 1,9. So from here, we have the dy divided by dx, which is equal to x to the power 5 divided by 5 plus x squared divided by 2 minus 2x plus 1,9. And we are going to multiply. We multiply both sides of the equation by dx, and that dx will cancel out, and dy will be equal to x to the power 5 plus x squared divided by 2 minus 2x plus 1,9, all of which is multiplied by dx. We introduce the integral sign both sides of the equation. On the left hand side, the integral of 1 with respect to y will be equal to y, and this will be equal to 1 divided by 5 multiplied by the integral of x to the power 5, which is x to the power 5 plus 1 divided by 5 plus 1 plus 1 over 2 multiplied by the integral of the x squared, which is x to the power 2 plus 1 divided by the 2 plus 1 and the integral of the negative 2x will be equals to negative 2 multiplied by x raised to the power 1 plus 1 divided by 1 plus 1. Let's create some space. The integral of the positive 1, 9 will be equals to 1, 9x plus our constant c1. Let's try to simplify. Y will be equals to 1 over 5 multiplied by x raised to the power 6 divided by 6 plus 1 over 2 multiplied by x raised to the power 3 divided by 3 minus 2 multiplied by x raised to the power 2 divided by 2 plus 1, 9x plus c1. Further simplification, we have y which is equal to 1 over 5 multiplied by the 1 over 6 which is equal to 1 over 30 multiplied by x to the power 6 plus 1 over 2 multiplied by 1 over 3 which is equal to 1 over 6 multiplied by x cubed. 2 and that 2 will cancel out and we have negative x squared plus 1, 9x plus our constant c1. From here we have to determine the value of c1 using our initial values. This time around we are just going to use the x is equal to 1 and the y is equal to 1 divided by 5. In the place of that y, we substitute 1 divided by 5. So 1 divided by 5 will be equals to 1 divided by 30. And in the place of the x, we substitute 1. So 1 multiplied by any number will just be equal to that number. So we have 1 over 30 plus 1 divided by 6 minus 1 squared which is 1 plus 1, 9 plus c1. And the 1 divided by 5 will be equals to 1 over 30 plus 1 divided by 6 minus 1 plus 1, 9, and this will be equals to 11 divided by 10 plus c1. We take this 11 divided by 10 to the left and it's going to change sign to negative 11 divided by 10 which is equals to c1. So the numerical value of c1 will be equal to 1 over 5 minus 11 divided by 10 which is equals to negative 9 divided by 10. So the value of c1, we substitute it into this equation. Finally, our particular solution, we have y is equals to x to the power 6 divided by 30 plus x to the power 3 divided by 6 minus x squared plus 1, 9x plus, in the place of the c1, we substitute negative 9 divided by 10. And this will be our particular solution for this second order separable differential equation.